Okay, this will be video 3 and probably the final video of section 5.2. We'll start up on 28. Once again, we have this function y equals x. And we're finding the area under it from A to, and be careful here, if you look carefully, it's the square root of 3 times A. The A is not underneath the radical. And if you look carefully, it shows that, but on quick first look, it looks like it might be under the radical, which is why I really would have preferred they wrote it as A root 3 instead of this. Okay, but be that as it may, we have a trapezoid. So the area is 1/2 of height, which is going to be root 3 times A minus A, which I can do nothing with, except maybe factor out an A, but that's still not going to make it very pretty, times the height, which is going to be A, and then this would be the root 3A. So that would be base 1A plus root 3A. And if I'd written it differently, it would have been more obvious, but what we have here are conjugates of each other. A plus B, A minus B, and that's the, if you notice that, then you know that that's the factoring for the difference of two squares. And so you can get to the answer a little bit quicker, but if you know all of that. But if you don't, then a simple FOIL will get us to the same place. So root 3A times A gives me root 3A squared. Root 3A times root 3A gives me plus root 3 times root 3 is 3. A times A is A squared. Minus A times A is minus A squared. And negative A times that gives me negative root 3A squared. And that's the beauty of the difference of two squares, that when you multiply it together, you get a negative and a positive. So we're simply left with an answer of 3A squared minus 1A squared, or 2A squared. Okay, now we get into a section on number 29, and we have to make sure you read the instructions. I didn't leave myself really any doodle room here, so maybe I'll just do it up here in the corner. They told us that the integral from 0 to 1 of x cubed, so if we sketch that real quick, x cubed is the function that looks about like this. We have the rotational symmetry, and they told us from 0 to 1, this area here is a fourth. And so given that, they want us to now answer some more questions. So we look at number 29, and it's asking us to look from -1 to +1. And again, the symmetry of the cubic function tells us that this area right here will be the same as the area from 0 to 1. The only difference being this portion lies below the x-axis, making a negative area. So we have -1/4 as the area to this guy, because this was +1/4. So when we add those two together, we actually get an answer of 0. So the net area would be 0. Net area meaning you take the positives and you take the negatives and you combine them together to see what you get. Okay, so now number 30, we've got the same graph of x cubed, but now we've moved it up 3. So as I go to sketch this, I go up to 3, and that's basically where my curve is happening. So I get a graph that looks about like this. But again, if we go back and think about just x cubed, so without the moving up 3, it'd be sitting right there. And the distance from 0 to 1, this area right here, is that area of a fourth that they gave us. And so now finding the area of the whole thing, I have a rectangle with with a length of 1 and a height of 3. So this area is 3, and this area is a fourth, and so the answer is going to be 3 1/4. 31, same idea. Again, I'm counting on you remembering how to translate functions that you learned in pre-calculus in Algebra 2. But we know that if we take the function x cubed and we change the inside of the function to x minus 2, we should remember that that means the function moves over 2 places. So what used to be located right here is now actually located, that's pretty ugly, right there. So the area that was from 0 to 1 is now from 2 to 3. So we know that this area is a fourth. And they ask us on 31 to look from 2 to 3, which is now where we're at. And so the answer is simply a fourth. And then we look at 32. So this one looks a little bit different. So let's think about this. The cube. So we plug a number in and we evaluate the absolute value of it. Then we cube it. So essentially what that's going to do is nothing to positive numbers, because the absolute value of a positive number is a positive number. So 0 is 0, 1 is 1, 2 is 8, all the things that the cubic function was going to be. But now instead of turning down, normally those positive numbers become, those negative numbers become positive numbers. So plugging in negative 1, it was just like plugging in positive 1, and that would give us 1 cubed. So essentially this turns into more of a parabola looking graph. And I know that 0 to 1 is the area of a fourth that they gave us. And this area right here, which was going to be negative a fourth because it was on the bottom, is now also a fourth. So when we add those two together, we get a 1/4 and 1/4, which is 2/4, which is 1/2. Okay, 33, 1 minus x cubed, which I prefer to think of it as x cubed, negative x cubed plus 1. So let's do this in a couple of stages. So x cubed is normally this guy. Negative x cubed would flip it over, and all the so if you ignore the plus 1 for just a moment, when I plugged in 1, cubed it, I was going to get positive 1, but now the negative flips it negative. And so I get the mirror image of this graph, which would look like this. So that's the graph of x cubed, negative x cubed. But now what are we doing to that? We're going up 1. So that would mean that this function, this red function, is actually going to go up 1. So that bend is now happening right here at 1. And the rest of it looks about the same. So it looks about like that. Okay. So that means that this little area right here, back up to this picture in black, this was the area that was a fourth. Flipped it over, and now this is the area that's a fourth, and that then moved up 1. So what I really need to do here is give myself a little guidance and know that hopefully we recognize that this is now that area that is a fourth. But I don't care about that area. That's not the area I want. I am now focusing on the area under the curve from 0 to 1. So I'm actually looking for this red area. And so, if we look carefully, if I include the red and the blue, then I simply have a rectangle with a length of 1 and a height of 1. So the area of the rectangle is simply 1 square unit. And if I take away the part I don't want, which is the blue, I get 1 minus a fourth. So this area is 3/4. So the answer to the integral is 3/4. That one's tricky, but if you just take your time and kind of build the picture, using all the rules you've learned in the past 2 years about translating functions, then you should get there. Alright, 36 is the last of these, and it's just like number 29. It doesn't matter that we're going from -8 to +8. It has nothing to do with the fourth anymore. But what this tells us, of course, is we're still symmetric. And so no matter where you start looking, you go all the way up to 8, and you go all the way up to -8. And those areas are still going to be opposite each other. And so the answer is still going to be 0. Okay, the final couple questions we're going to be using our calculator for. And so it is really as simple as making sure you type it in the calculator correctly. And then you know how to use the integral function. So I'm at 10.5 minutes already. I'm going to do this very quickly. If you need to rewind or pause or whatever you need to do, then do so. So I'm going to use the method where I put this into y1. So I'm going to get x divided by parentheses, x squared, plus 4, close parentheses. And so now that's stored in y1, and now I'm going to go on my main screen and go to math, and go to math 9, I believe it is. So then the notation is, so you get FNINT, and then the notation is now y1, because that's where I stored it, and then I got to put x, which represents dx, and then now I've got the a and the b, which represents my lower and upper borders. So a would be 0 in this case, and b would be 5. So as I hit variables, VARS, y variables, function variables, y1. Now I do a comma x, now I do a comma 0, and comma 5. And I get an answer of approximately 0.990 excuse me, 05. So make sure you are writing your answers to at least 3 decimal places of accuracy. Okay, so now we get to number 40, and let's take a look at this math right here. If we think about order of operations, this is a function, and I'm doing some math with it. So let's do it this way. If I take away the 3 and the +2, the 2 is being multiplied by whatever this is. And so what I need to do is find the answer to this, and then I just follow the math, which says multiply by 2 and then add 3. So I need to go up to y equals, and I'm going to change my function now to tangent x. And it occurs to me before I go any further, I just want to make sure nobody's messing with my calculator, and I am in radian mode, and that is the case. So then I'm going to go to math 9, and now I'm going to put in the function again, comma x, comma 0, comma pi divided by 3. So I get that answer, which is now giving me 3 plus 2 times, and I got 0.693147, etc., etc. So multiply by 2 and add 3, and I get an answer of approximately 4.386. Okay, so 42, it's now asking me really to do the same thing. It's asking it in kind of a weird way, but it's asking me to look at the function of y equals x squared e to the negative x from that to the x-axis. So if you want to look at what it looks like, go ahead and graph it, and just to kind of make sure everything looks good. But I don't think there's going to be anything weird here. So x squared e to the negative x. So I'm going to do a zoom 6 and just take a look at this graph. Alright, I got myself a strange looking little graph that appears to do something like come down here, maybe hit the 0 at 0, bounces up a little bit, and then seems to level off with an asymptote. Not that any of that matters, but now they're asking me to find the area from -1, wherever that is, to 3, whatever that is. Which would normally seem like it'd be pretty challenging, but I can do this using my calculator. So I go to math, 9 again. Variables, y variables, function y1, comma x, comma -1, comma 3. And I get an answer of approximately 1.8719. Actually, let's do a little experiment. I'm going to take it out a little further. 0, 1, and then a whole bunch of 6s. And then let's try the other method just to see what happens. So I've already got this thing graphed. So now I'm going to go to calculate, and I'm going to do number 7. So I did second function trace, and then I chose calculate. I'm going to pick number 7 for the integral. Lower limit, I'm going to type in -1. Upper limit, I'm going to type in 3. And I get 1.871917. So very accurate, way out here to at least, what, 5-6 decimal places. So at least for that one experiment, I get the same answer. We should keep checking intermittently as we do these problems just to see if there's ever any example where we don't get an exact, exact match. Okay, that's it. That's the end of the assignment. And let me know if you have any questions.